For sure.
It's crazy. The stuff that we have now is beyond imagination. It's essentially magic for people 100 years ago. It's ultimately going to lead to a life form.
People will worship AI as a god.
It's crazy to think about how advanced our technology has become. What we have today would seem like magic to people 100 years ago. And as AI continues to evolve, some believe it could lead to something so powerful that people might even worship it. Something just happened in the world of AI and space exploration, and it's bigger than anyone expected. For years, artificial intelligence has helped scientists decode the mysteries of the universe. But when researchers fed raw data from Proxima B into Grok 3, one of the most advanced AI models ever created, they uncovered something completely unexpected. They expected standard atmospheric readings, but what they got instead could change everything we know about this planet. This could be the biggest clue yet about whether Proxima B is habitable, or hiding something more. And what Grok 3 just found will leave you speechless. Proxima B has long been a subject of debate among scientists. Some believe it could support life, while others argue that its conditions are too extreme. Despite years of research, much about this planet remains unknown. Traditional methods rely on analyzing light patterns, atmospheric compositions, and radio signals, but the sheer volume of data is overwhelming. This is where Grok 3 comes in. Its advanced AI capabilities allow it to detect patterns and anomalies that human researchers might miss. Scientists expected it to refine existing models and confirm what they already knew. Instead, it uncovered something entirely unexpected. So, what happens when one of the most advanced AIs ever created analyzes Proxima B? The results are unlike anything we've seen before. Scientists fed raw telescope data, climate models, and radio signal patterns into Grok 3 with one objective: identify anything unusual. Climate patterns, water signals, or anomalies, anything that could provide new insights. At first, the AI processed the data as expected, refining atmospheric models and mapping potential surface conditions. But then, something unexpected emerged. A pattern that human researchers had overlooked. A signal that didn't align with known planetary behavior. And then, something truly strange happened, something never seen before in exoplanet research. Grok 3 detected an anomaly within Proxima B's light emissions, a repeating pattern that initially appeared to be ordinary cosmic noise. But when scientists examined the data more closely, they realized the signals weren't random. They followed a precise mathematical structure, something that doesn't typically occur in nature without a clear underlying cause. This discovery alone was enough to warrant further investigation. But then came something even more unexpected, an atmospheric anomaly that defied existing models. Proxima B's environment was thought to be harsh and unstable, yet Grok 3 detected something highly structured within its composition. It was as if the planet's atmosphere was reacting in a way that couldn't be explained by known geological or meteorological processes. The implications were staggering. If the anomaly was natural, it could point to an entirely new type of atmospheric behavior, something never before observed in an exoplanet. A process so unique that it might reshape our understanding of planetary evolution. But there was another possibility, one far more unsettling. What if this pattern wasn't the result of natural forces at all? What if it was something else? A phenomenon that, despite being organic in origin, behaved in a way that seemed designed. Could this be the first real clue that something extraordinary is happening on Proxima B? Grok 3's discovery presents three possible explanations, each more intriguing than the last. The first is that Proxima B is experiencing an entirely new type of atmospheric process. Scientists have observed strange weather phenomena on exoplanets before, but nothing like this. If the signals Grok 3 detected are the result of atmospheric activity, it could mean that Proxima B's climate operates under conditions never seen elsewhere. This would challenge existing models and force researchers to reconsider what makes a planet habitable. The second possibility points to a geological anomaly. Proxima B endures constant radiation from its star, and some theories suggest its surface could be shaped by extreme volcanic activity or powerful magnetic fields. If the light emissions detected by Grok 3 are linked to these forces, it could reveal an entirely new class of planetary geology. But even this explanation raises more questions than answers. Then there's the third, and most controversial, possibility. What if the signals aren't the result of natural processes at all? What if the structured patterns indicate something more deliberate? Scientists have long theorized that advanced civilizations, if they exist, might leave behind technological signatures, evidence of artificial structures, energy manipulation, or even direct communication attempts. Could Grok 3 have just stumbled upon the first hint of such a phenomenon? This leads to the biggest question of all: if this is a natural event, why haven't we seen anything like it before? And if it's artificial, who, or what, could be behind it? With so many unknowns, scientists have no choice but to investigate further. Advanced telescopes are already being reprogrammed to focus on Proxima B, and teams are preparing to analyze the data more closely than ever before. And here's the craziest part: scientists believe they might be able to test Grok 3's discovery soon, and the results could be game-changing. Confirming Grok 3's findings is now a top priority. The James Webb Space Telescope, along with several next-generation exoplanet observatories, will now dedicate observation time to analyzing Proxima B's atmosphere in greater detail. These instruments can detect specific gases, temperature fluctuations, and light variations that could either confirm or disprove Grok 3's findings. Meanwhile, astronomers are working on new signal detection algorithms designed specifically to cross-check the AI's results. If Grok 3's anomaly is real, these updated methods should be able to verify it independently. And if that happens, it could mark the first true breakthrough in the search for life beyond Earth. But the implications go beyond just Proxima B. Scientists now plan to refine AI models and apply them to other exoplanets, scanning for similar signals. If multiple planets show the same pattern, it could suggest a universal but previously undetected natural process. However, if Proxima B is the only planet exhibiting this anomaly, that raises an even bigger question: why? What makes this world different from all the others we've studied? And if this is something artificial, what happens if we respond? Grok 3 has uncovered something on Proxima B that no one expected: a structured pattern in its light emissions, an atmospheric anomaly that doesn't fit known models. Something that could rewrite what we understand about exoplanets. Now, scientists are racing to uncover the truth. Is this an unexplained natural phenomenon? A geological or atmospheric process unlike anything seen before? Or is it something far more significant, something that suggests intelligence? Whatever the answer, this could be the biggest clue yet in the search for extraterrestrial life. And with more powerful AI models and advanced telescopes coming online, this may only be the beginning. If Grok 3 can find this now, what will future